let's take a look at the questions on homework number 7. I'm going to skip straight down to the third topic because the first two were covered on the homework number 6 video. For these questions, you're going to practice graphing your straight lines by using the y-intercept and the slope value. The y-intercept is the point on the y-axis. So we're going to go to the y-axis and we're going to graph a point at +1. From there, we're going to follow the directions of our slope. Remember, the directions of the slope are rise over run. And a rise is moving up or down. And a run is moving left or right. So for us, our slope says -5/3. Now the first thing you need to do is deal with this negative sign. You have one negative sign, but you have to give it to one of these numbers, either 5 or 3, but not both. So typically my suggestion is to take that negative sign and put it next to the numerator, because it's easier to decide whether you should go up or down than it is to go left or right. So because this is a -5, that means we're going to go down 5. And because this is an invisible +3, that means we're going to go to the right. So from our initial y-intercept, from that point, you're going to travel down 5 units, 1, 2, 3, 4, 5. And then you're going to travel 3 to the right, 1, 2, 3. And this is where your next point will be. So when you're using the Delta Math app, what you're going to do is click one time at the y-intercept and then drag your mouse or trackpad down 5 and then 3 to the right, and you'll see a line appear. Click one time in that location and you're done. Submit your answer and let's try another one. Again, the first thing you do is always graph the y-intercept. Now in this case, our y-intercept is -3. So that means we're going to plot a point at -3. Now our slope this time is a whole number. But slope must have 2 directions. So if you don't have a denominator, you fill it in with an invisible 1. +2 means up, +1 means right. So again, with your mouse, you're going to click one time here, one time at -3, and then 2 up and 1 to the right. All right, let's try one more. This time, they tried to trick you, so pay attention. The y-intercept is here in the second row. The y-intercept is -3, so you plot a point at -3. This time, the slope is +5/3. Remember, the top number is always up or down. The bottom number is always left or right. So from our initial y-intercept, we're going to count 5 units up and 3 units right. Now notice when I'm counting that I move from one corner of a box to the next. So 1 corner, 2 corners, 3 corners, 4, 5 up, and 1, 2, 3 to the right. That's where I'm going to click my mouse. So -3 is my first point, and then 5 up, and 3 to the right. Okay, let's take a look at the next topic, graphing lines from equations. Now this is the same skill as what we just did for the previous task, except they're not going to explicitly spell out for you which number is the y-intercept and which number is the slope. But you still need those 2 values in order to graph. The y-intercept is always the constant, and the slope is always the coefficient of x. If you don't see it, fill it in with a 1. So I don't need the letter x for my slope. That's just where the slope number is located. So for us, we didn't see a number. We saw a negative x. So we're going to put that 1 in the front there, and we're not going to use the x in our movement. So -1 is the rise. And now we need a run. So the run is +1. So with my mouse, I'm going to click the y-intercept at 5, and then from there, I'm going to rise -1 and run +1. Let's try it one more time. Pay attention to your y-intercept and your slope. The y-intercept this time is a -5. And the slope is the fraction 1/5. Remember, the numerator is the rise, the denominator is the run. So I'm going to plot my first point at -5. I'm going to rise 1 and run 1, 2, 3, 4, 5. Click Submit. All right, let's try this one more time. I see my y-intercept, it's -4, but I don't see my slope. So that means I fill it in with an invisible 1. And if it's not a fraction, then I put a 1 in the denominator. So I'm going to start graphing at -4. I'm going to rise 1 and run right 1. Let's take a look at the next topic. This one asks you to find some basic patterns in a table. So you notice here that my x's are going by 1s, and I have to do some math here to figure out what's going on with my y's. So I know that 13 to 22 is definitely getting bigger, 22 to 31 is definitely getting bigger, and 31 to 40 is definitely getting bigger. Now I know that this is an increase of 9, so I'm just going to check to see if these are also an increase of 9. 13 plus 9 is 22. 22 plus 9 is 31. So now I know that the pattern here is to add 9. So all I have to do is add 9 to find my next missing number. Let's submit our answer here. 49. Let's do it one more time. Check to make sure that your x values are increasing by 1. And then here, you're going to look for a pattern. If you're not sure mentally what the pattern is, then go to the last number and subtract the one before it. This is called a difference. Take the last number and subtract the one before it. So 17 take away 12 is +5. So that must mean that the pattern is +5. So now I can find my missing value. So if you can't mentally figure this out, try subtracting the last number from the one previous to it. This trick works as long as this is going by 1s. So now you can fill in your answer. Again, if your y's are if your x's are going by 1s, then you can try subtracting the last y value, take away the previous y value. So you can use a calculator to compute that. 42 minus 33 is +9. So that means that my pattern was add 9 each time. And now I can find my missing number. Let's move on to the next topic. In order to identify if an equation or table is linear, you must have a constant rate of change. That means that the pattern on your x's and your y's has to be the same each time. So we call this a change in y and a change in x, right? Delta y is the change in the y numbers, and delta, right, that's that Greek letter there, delta x is the change in the x numbers. So let's take a look and see if we can find that pattern. So here we have +1, +1, and then we have +2. Okay, that can happen, but only if the pattern on the y side will also change. So let's see, from -2 to 1, that's moving up 3. From 1 to 3, that's moving up 2. From 3 to 7, that's moving up 4. So my change in y's and my change in x is not the same every time. The first time, the change in y was 3, and the change in x was 1. The second time, the change in y was 2, and the change in x was 1. These are not the same. And then the third time, the change in y was 4, and the change in x was 1. So this is not a linear relationship. Let's try the next one. +3, +3, +3. This is looking good. Over here is +3, +3, +4. So I already know that 3/3 is equal to 3/3, but 4/3 is not equal. So this one is not linear. Let's move to the next table. The change here is +2, +2, +2, -2, -2, -1. That's not linear. Let's take a look at the last one here. +3, +6, +3. So +2, +4, +2. Now let's take a look at that pattern again. The y over the x for the first one was 2/3. The y over the x for the second one is 4/6. Now these numbers don't match, but 4/6 is the same as 2/3 when I reduce it in half. And then the last one was also 2/3. So all of these have the same pattern. That makes this a linear relationship. So we're going to select letter D as our option. All right, let's do this again. Again, we're looking for the pattern of the y's over the pattern of the x's to be consistent, to have a constant rate of change. Okay, so I went ahead and I wrote down the change in all of the y values and the change in all of the x values. And now I'm going to look at my fractions here to see what we've got. I've got, in letter A, I've got -3/3. And then -2/1. These are not a match, so that is not linear. For letter B, I've got 6/9. And then I've got 3/4. Well, I know this can be reduced by 3, but I'm not going to get 3/4. I'm going to get 2/3, so this is not a constant rate of change. For here I've got 1/5, over here I've got 1/5, and over there I've got 1/5. That is constantly the same rate. So C is the winner. So for each question, you're going to go down and you're going to look at the pattern between the points. For this one, you're going to look for something different. The points will not be given to you organized in a table. So I probably would make a small sketch for each question. -3, -6, -1, -2, 1, 1, and 3, 5. And I would look for that pattern. This is going up 4. This is going up 3. This is going up 4. I'm already seeing something inconsistent here, but let's just double check. This is going up 2, this is going up 2, this is going up 2. Well, if this is constantly the same, this needs to be constantly the same, so that means that letter A is not a linear function. Let's do the same task with item B. -9, 8, -4, 4, 1, 0, 6, -4. So it looks like I'm going down 4, going down 4, going down 4. This is looking really promising. I have a constant pattern over here, so let's check the x's. It's going up 5, up 5, up 5. This is a winner. -4 over 5 every time. So B is the correct solution. Let's move on to the last topic, interpreting graph stories. Now this one has quite a bit of reading in it, but really what you're focusing on is the question down here. How far away from her house was Alexandra after 14 minutes? So let's go back and read the beginning here to see what's going on. Alexandra left her house and then drove to the store. So this is her driving to the store. Right. She stopped and went inside. From there, she drove in the same direction until she got to the bank. She stopped and went inside the bank, and then she drove home. So hopefully you can kind of visualize what's going on in the graph. Now let's reread the question. How far away from her house was Alexandra after 14 minutes? Well, first, we need to go to our x-axis, which is talking about minutes, and find 14, which is here. Now we're going to travel up until we meet the graph. We meet the graph here, and that will tell us how far we are. 15 blocks from her house. So we're going to type that into the answer box. Let's try another one. Mamadou left his house and drove to the store. He stopped and went inside. From there, he drove in the same direction until he got to the bank. He stopped and went inside. Then, he drove home. The graph below shows the number of blocks away from the home Mamadou is X minutes after he left, until he got all the way back home. Now let's take a look at the question. At what rate did Mamadou travel from his house to the store? Well, the store was the first place he went. If you remember, he went to the store first, and then he went to the bank. So they're asking how fast did he travel on his way to the store? And your rate of travel is your slope. The change in your y over the change in your x. So let's take a look at that. From here to there, how much did my y values change? Looks like I went from 0 all the way up to 12. And then how much did my x value change? Looks like I went from 0 over to 2. So that means 12 divided by 2 is 6, or 6 blocks per minute. 6 blocks every 1 minute. That's another way you could say it. 6 blocks every 1 minute. Let's take a look at one more story. Tariq left his house and drove to the store. Then he stopped and went inside. From there, he drove in the same direction until he got to the bank. He stopped and went inside. So it's the same story, similar graph, and let's take a look at this question. How long was Tariq in the bank? Well, this was to the store, and this was to the bank. So this is how long Tariq was in the bank. We need to calculate this amount of minutes. So we traveled down to the x-axis to see that he started going to the bank at 10 and then came out of the bank at 14. So that's a change of 4 minutes. So we're going to type that in the answer box. And that concludes our homework number 7 tutorial.